Hello and welcome back to Calculus 1 section 4.2 on the mean value theorem. This theorem connects the world of average and the world of instantaneous. And we know that those two worlds are not the same because the average world takes all of the possible points into account and averages them, where the instantaneous change is the one where you find the change at an instant. And I made a comparison between an instant, which is a photograph, and average over a long period of time, which is the movie, like the movie, right? Video. So now we are going to see how those two worlds are connected. But before we do any of that stuff, let's work out something interesting. So now this is going to be a stretch of a highway. We'll place you in a car right here. Put some tires on this thing. There we go. And you are going to be in a 60 miles per hour speed zone. I'm gonna put some shrubbery over here, and we are going to put another car right there. This car is going to have Christmas lights on it. There we go. And then let's say 10 miles down the road, we're going to place another car with lights also. So we know what this situation is, right? It's called a speed trap. Now, this one will be measuring right here. This one will be measuring right there. They're 10 miles apart. And since you invested in one of those radar detectors, as soon as you approach the first speed trap, it's going to go off, and you are going to go through the speed trap at 60 miles per hour at, let's say, 3:16 p.m. And you are not going to be pulled over because speed limit is 60, and you drove 60 through the speed trap and there are no issues. And then you are going to continue down your trip, and then at 3:24 p.m. you are going to go through the second speed trap. Well, your radar detector will go off again, right, alerting you that there is a speed trap, so you make sure you're driving exactly 60 and you are not going to get pulled over. Couple of days later, the ticket arrives in the mail. Do we have anyone in this situation? Or do you know anyone who was in a situation? I got a speeding ticket in the mail. I was never pulled over. This must be a mistake. No? Yeah? Okay. Because in my other Calc 1 class, no one would admit to it. Generally, when I have a class of 30, either someone directly or someone very close to the person, whether it's a friend or family, was in a situation where the ticket just arrived in the mail and they were never pulled over. Whoa, what do you mean? What happened? We only know that if the speed is measured directly, and that's instantaneous velocity, instantaneous speed, right? Then you get pulled over. Well, let's see what the average calculation is going to give us in this applied problem. We know that the speed is the distance divided by time. The distance is 10 miles, and the time was 8 minutes. So I need to get rid of these minutes because we like to measure our speed in miles per hour. So 1 hour has 60 minutes. And when I multiply and divide these numbers, right, I'll have 600 divided by 8. Minutes and minutes will cancel, and I'll just have miles per hour. And now all I need to do is to divide 600 by 8 to get 75 miles per hour, which is 15 more than the speed limit. But now you will say, hold on, that was average speed. Yes, that means you did worse than 75 to average it to 75. If 75 is the average and you pass through both gates at 60, right? That means that you have to go way above 75 so you can average the lower speeds of 60 to get it into average of 75. Now, obviously, they can't prove any of those, but they can definitely prove from 7 to 75, which is today's theorem. 75 miles per hour in this situation here is what we call average. Now, the mean value theorem is a theorem that says that if the function that you're observing is continuous and differentiable, you are guaranteed to have at least one point where average is the same as instantaneous. Now, those are the slopes of the line. So technically, if you have any kind of a function and you pick two values as a and b on your f of x function, you know that the line that connects those is m secant, which is your secant line. Now, what you need to do is to figure out the same slope, so there has to be a parallel line to m secant, and whenever that one crosses is going to be that value c. And what you see over there is the slope of the secant line and the slope of the tangent line are the same because we know that parallel lines have the same slope. So we are going to see over here that m secant is equal to m tangent. And this is where the world of average equals the world of instantaneous. Now you get ticketed for instantaneous. And this theorem is the one that connects the two worlds. So that's why the ticket is in the mail, because the average said average speed is 75. What do we know? The road from point A to B is continuous road. You didn't teleport on any of those locations. And then also what we know is that it's differentiable because going from point A to point B, you are using velocity, which is derivative of position. So the function was differentiable and it was continuous, and that's why all conditions are satisfied. When you satisfy the conditions, you get to equal the two and And then we have average equals instantaneous. So average equals instantaneous, meaning slope of the secant line is equal to slope of the tangent line. So that's the theoretical part. Here's a theorem. Now, this is one of those statements that you might be asked to state on the exam, the way it is stated. So if f of x is continuous on some closed interval a, b, and differentiable on open interval a, b, then there is at least one point C in AB such that, and here is the formula that you will be using, f prime of C is equal to f of B minus f of A divided by B minus A. So the left side is the derivative, which is your instantaneous side, and then the right side is your average, which is slope of the secant line. It's just the algebraic slope, y2 minus y1 over x2 minus x1, which is your average side, which is the slope of the secant line. And that's it. That's the concept. So you see it in a graph up there. If you want me to color code this, then I would have to put this side of the equation blue, right? If you want me to follow the colors I used up there for tangent lines. So you have the slope of the tangent line on the left and the slope of the secant line on the right, one representing instantaneous and the blue one representing the average. So now we can do some, actually I'm going to bring this back into red now, because it's a part of the very important theorem. And now we're just going to solve, whatever blah blah example that has no application, is just for us to calculate things. And that one could be, well, let's do the basic one, like f of x equals 7 minus x squared on the interval -1 to 2. All right, so the first thing is we have to check the conditions, which is why you might see this on your exam in a question, state the mean value theorem. These two conditions, continuous and differentiable, are crucial. If any of those two conditions are violated, this theorem doesn't hold. If the function is not continuous, or if it's not differentiable, then the condition doesn't work. So now we have, this is a polynomial. All polynomials are always continuous on the entire domain. And then they're all differentiable as well, so they don't have any spikes or cusps or vertical tangencies or vertical asymptotes, right? So none of that stuff. So let's go and take a look at the derivative. So the derivative f prime of x is -2x. Now this is the most confusing part for everyone. The formula is calling for f prime of c. So if f prime of x is -2x, then f prime of c is -2c. So now our f prime of c equals f of b minus f of, I have b and a, sorry. So b and a are given. My b is 2, my a is -1, and then 2 minus negative 1. There we go. So f prime of c is negative 2c. F of 2 is 7 minus 2 squared minus 7 minus negative 1 squared divided by 2 plus 1. Negative 2c is equal to 7 minus 4 minus 7 plus 1, because square will kill the negative, and you still have negative 1, and then the negative from the front divided by 3. So this is now going to be negative 6c is equal to negative 3. C equals 1/2. There we go. So for the interval negative 1 to 2, you have 1/2 where the slope of the tangent line and the slope of the secant line will have the same value. You can check that because you can find those slopes. So clarification over here. At c equals 1/2, slope of the tangent and slope of the secant line are the same. There we go. All right, one more example. So you find the derivative. Then you put that derivative in terms of c because you need f prime of c. And then you are solving, c is your variable, right? You're solving for c. Everything on the right hand is given because you have the function, you have the points. It's always f of b minus f of a, so you plug all of those in, and then you just plow through calculation. Eventually you'll have a c, and that's it. You're looking for that c, because that's the x location at which the tangent line will have the same slope. Let's see. Since you had a question about the quotient rule, derivative, here's the opportunity for you to practice it. Oh, it's the same interval. Okay, interval can be anything. This is just bad luck over here. 2 examples back to back with the same interval. All right, so we start with the derivative, f prime of x. So we have x plus 2 squared, x plus 2 times 1 minus x times 1. That's x plus 2 minus x divided by x plus 2 squared, which is 2 over x plus 2 squared. That means that f prime of c is 2 over c plus 2 squared equals 2. And now we plug in f of 2 minus f of negative 1, 2 minus negative 1. So we have 2 over c plus 2 squared is equal to f of 2 is 2 over 2 plus 2 minus f of 1 is negative 1 over negative 1 plus 2 divided by, we know it's 3. So 2 over c plus 2 squared is equal to, so 2 over 4, that's 1/2. Minus and minus will give me a plus 1/2. No, that's a lie. Plus 1. There we go. Divided by 3. So how much is that? That's 3/2 divided by 3 is say over 1. So the whole thing becomes a half. Great. So I have 2 over c plus 2 squared is equal to a half. You want to cross multiply, that's fine. 4 equals to c plus 2 squared. And now when you square root both sides, usually you forget the plus and minus, and that kills half of your solutions. So, plus minus 2 is equal to c plus 2. So now what you have is that c is equal to plus minus 2 minus 2. That breaks into two solutions. There is a c 2 minus 2 equals 0. And there is a c negative 2 minus 2 equals negative 4. So we have two c values in this case that would have whose slopes will line up with the slope of the average. So c equals 0 and c equals negative 4. Now, a couple of examples that they give are all the same, actually. So they give us the mean value theorem and the police, which is what we did first. Then the next problem says mean value theorem and the police again, which is another problem with different numbers. Then they have running pace, and then they have the 100-meter dash, which is also running. So everything is velocity and speed related in terms of mean value theorem, in terms of these application problems. So one of these problems is given in meters, the other one is given in feet. So since you are more accustomed to feet, I'm just going to work out the one that it's in meters. So 100-meter dash. So they say the Jamaican sprinter Usain Bolt set the world record of 9.58 seconds for the 100-meter dash. So distance is 100 meters, and the time was 9.58 seconds. in the summer of 2009. Did his speed ever exceed 37 kilometers per hour? Did the speed go over 37 kilometers per hour? Now, you know that if this was in miles per hour, the answer would be hell no. But kilometers, you don't really know. So what are we going to do? Well, we are going to do the same what we did for the police problem up there. You are going to say that the speed is equal to distance over time, and you will calculate the average speed. And once you have the average speed, because of the mean value theorem, it's right, the road was continuous, right, continuous running, and it's the speed is right derivative of the distance, so everything is differentiable. We can use the parallel between the two. So distance over time, the distance was 100 meters and the time was 9.58 seconds. Now, we don't like seconds, we want hours. So you put seconds in the numerator to cancel it, and hour in denominator. So 1 hour has 3,600 seconds, and then seconds and seconds will cancel. And you also want to cancel meters and have kilometers. So now, since you're canceling the unit that is in the numerator, you will put that unit in the denominator, and the one you want to go to the opposite side. Now, 1 kilometer has 1,000 meters. And now, meters and meters will cancel. So now, you can cancel a whole bunch of these. You can cancel 100 and one of these zeros with 1,000. And you are left with 360 kilometers divided by 9.58 hours. And that will give you the value when you divide these two numbers. So we have 360 divided by 9.58 is 37.6. So the speed we get is 37.6 kilometer per hour, and that's bigger than 37 kilometer per hour that they are wondering about. So yes, he did run faster. He actually ran faster than 37.6. We don't know how high they went, but definitely, at least, 38, at least 38 kilometers per hour. If 37.6 was the average, and think about it, right? When the runners start the race, they start at zero velocity, right? In that stance on the ground, and then when the shot is fired, they get up and start running. So there is a certain amount of time that passed for him to actually speed up to 37. And then also there is additional amount of time when you're stopping on the other end, right? So yeah, there was definitely possible. Right? If you want to know the speed in miles per hour, you will divide by 1.6. And he was going about 23.5 miles per hour. That's almost 25 miles per hour, right? He's not breaking that speed limit, but it's out there. The fastest man on the planet can't even break 25 miles per hour. Yeah, we're doing great as a species, right? Woohoo! I know. It's awesome. So that's the mean value theorem. It's a statement which connects average and instantaneous. You'll have few of these problems to practice and enjoy. Homework is opened. So next class is going to be it's going to be very important. We are going to analyze functions using first and second derivative test, and we're going to analyze min and max, and we're going to set the stage for graphing complicated functions by hand, which means that you guys should not miss the next class. See ya.